Observability is one of those topics that is just so broad. You can think about it in so many ways. Today, we're going to talk with two experts in the space who are going to give us their perspectives on observability today and what you really can take from this conversation and perhaps even apply it into your own world, into the own engineering that you're doing. Joining us is Bartek Plotka, principal engineer at Red Hat. He is the SIG observability tech lead. He works on Thanos and the Prometheus maintainer. I believe you're one of the creators of Thanos. Isn't that right?
Yeah, that's correct.
Excellent. And Richard Hartmann, director community at Grafana, Prometheus maintainer, OpenMetrics founder, SIG observability chair. Hi, Richard.
Hi.
I think you go by Richie, right?
Richie or Richie H, but in spoken, it's usually Richie.
Richie. Okay, great. All right. So let's just get it started by looking at observability. You know, it's such a simple term and it can relate to so much. I was actually looking at the roots of the word and I didn't include it here, but it really is just like the English language. It's just full of semantics. So I'm curious what it means to you and how it has started to mature a bit as a concept in the work that you're doing and seeing around the world.
So the observability has a large aspect of being a buzzword, and obviously being a buzzword, some meaning gets lost, and people just try to, whatever they're doing, they just apply the stamp to it, of course, money. But it also is very useful. Historically, you were talking about the initial definitions, or like from control theory, where it's defined as being able to make deductions about the internal state or deduce the complete internal state of a system just by looking at inputs and outputs, which is a rather dry thing. But as opposed to monitoring and they're largely overlapping, but the focus of observability is a lot more about making humans understand or enable humans to understand what is actually happening, what might be broken, what is running well, and actually work with the data and extract new knowledge about the system from that data, instead of with the old style monitoring system. You have one graph, you have some threshold, and that's it. As it matures, I think there is more and more of an understanding of that it actually is about making humans understand what is happening, but also you have a ton of interfaces to machines. Of course, this is already machine readable format. As such, you can also make machines understand this data. And there's other buzzwords, AI, ML, and such, but the point is treating system state and insight about system state as a little bit of a pipeline on the new source of information, and not just one thing you look at and you're done.
Yeah, I think that's a solid definition. For me, observability is I would kind of name it as something more practical. The ability to essentially debug your application when it's on fire, when you really don't know what's happening, why it stopped, why it's so slow, why it doesn't handle the amount of requests you would expect it to handle. And they can, those observability signals, they can, take many forms. And it is usually bound to the basic elements. We call them three observability pillars: metric, logging, and tracing. But that's not the thing, and it's sometimes very fuzzy what is between those signals, and there are more signals right in the space, like for example continuous profiling, and maybe we are exploring, we are kind of doing lots of experimentation how to correlate each other and how to kind of navigate through those, and at the end, who knows what else user would find super useful, based on those kind of practical elements we used to know. So it's pretty exciting space.
That leads me to questions about the setup of observability platforms and what it requires and who's doing the work. I think this is part of the maturity now that we're seeing. It's people are starting to use observability a little bit more, but there's lots of unanswered questions. I'm wondering what some of those questions that you hear people talking about.
So as to the platform, this depends to some extent on what you're actually doing.
Yeah.
Some who's only doing some microservice architecture in the cloud will have a lot more tracing than someone having some legacy system which still keeps printing money. So it depends on what you want to have. The two things which are usually or commonly the two things with which people usually starts are logs and metrics. For the simple reason that pretty much everything is able to extract logs and log lines, and there's plenty of things which can emit this kind of signal. The other metrics, especially anything which is in large scale and has been in large scale for quite some time, tends to go towards metrics. You've seen this in ISPs and internet networking like 20 years ago, and you've seen this in cloud native technologies as well. Of course, a lot of those things, you have so much state, you have so much stuff going on that you cannot at some point have all the details anymore. So either you sample and you drop stuff, or you just introduce counters and other numeric data, which gives you a simplified view of what is going on. The beauty of this is that you can already optimize a lot in favor of humans understanding this well, and also storage costs and such, and overhead to operate all of these is super low for metric system as compared to a few others. Of course, the amount of data is just a lot lower.
So go ahead, because I'm curious about internet networking, and the internet is a network of networks, right? And it's essentially kind of thinking about how do you what is that visibility there, and you can think about it in different ways. You can think about it of the observability in the network stack, or you can think about in the programming stack.
So I think there's two answers to your question. So FYI, I've been doing ISP networks for 15 years or so. I stopped doing it, but this is the large part of my career. So I see a lot of parallels between internet and cloud native, and I keep joking or saying that what is cloud native scale and all the cloud native problems are basically the problems which have been solved in the networking space 2 decades ago, and this is roughly true. Of course, that scale, which was the internet back then, is what a single large provider can now have in total state, like not precisely, but roughly. So a lot of those learnings and a lot of the problems we are hitting in the cloud native space, I just go back to the networking stuff. Of course, there are already best practices and such. What was the other part of the question?
I was asking about the networking stacks, and like in networking and observability related to networking, both on the programming stack and the network stack itself.
That's a super interesting point. Because there is, from modern observability point of view, there is no difference if you have run a network or if you have an application, or if you are still in the physical data center and you have your diesel genset running or not running, or your HVAC. All of this is part of the service. Obviously, there's different people and different teams caring about all of this. You might also be in a cloud provider, blah, 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 blah. Point being, all of this is the stack which makes your service. And by having modern tools, what you can have is you can this complete overview through your system. So if you have high latency on some user-facing service, you can go down to the complete stack where the actual thing is happening. And the seamlessness and seeing a holistic converged view of your complete stack, not the observability stack, but your complete stack, is insanely powerful. Because it breaks down those things where one team does APM and one team does networking, and one team does long haul networking, and one team does the database and everything. No, you allow all those teams to bring their monitoring and observability data into the same systems, so you get this one holistic overview.
Yeah, and I would like to kind of plus one on this, like essentially in the modern kind of organizations, kind of what I seen, what was very popular is starting with actually metric signal, because of this hype that Google created with site reliability engineering. Like in the book, even you can read that logging are not the most efficient way of solving observability for you. You can rely on metrics a lot from the start to understand your application for the cheaper cost, essentially. And this is what I see in my career. We always started with metrics and then built up logging and tracing and maybe profiling at the end. And how it looked in many cases is that it was started as some infrastructure team that was then everything was scaling, more clusters, more workloads, and the infrastructure team were kind of ending up being a platform team, a core infrastructure team, which was responsible for this, having a compute power. So maybe establishing some Kubernetes or setting something on the cloud provider. And this team has this unfortunate role of making sure also observability works, that for other teams to use, for other applications to gather, to allow to collect the data and visualize it and alert on it. And this is the team that has the responsibility also usually to talk to the cloud provider and fetch and export metrics from their services, right? Because you want to know what your Google load balancer or Amazon load balancer what traffic it was seeing and what latencies you are using. So you want observability from those. So the integration part becomes a very critical portion. I mean, finding those integration parts, building, it's one of the most important parts as a core infrastructure engineer, to build the observability platform. And then when the organization scales, they think about, okay, I think we need observability platform, dedicated observability platform team. But this is how I've seen the things were scaling out in terms of team management too.
So what's happening to that infrastructure team now? And as the space matures, who's being affected, and how is it manifesting?
It depends on how willing the org is, I think, because if you do this right, you can use those tools in highly unexpected areas. One example from my past, for legal and compliance reasons, we had in a previous life, we had to give monthly overview of how many email accounts are managed by that service provider. And that used to be a manual run, and then you put stuff in Excel, and then they ran some analysis, and then they created a PDF, and they mailed it to a different person. That person cross-checked. They mailed it to a different person, and that person then told the authorities. I just built a dashboard, and she literally just got that number out of the dashboard and gave it directly to the authorities, bypassing everything else. That ties back to this automation aspect and having data in machine-readable formats, which allows you to actually work with and on the data, as opposed to just looking at it. But as this data becomes malleable, you go into more and more aspects of a whole org, or you can. It depends on how willing the org is to actually allow this kind of thing.
Bartek, the integration issue is becoming a primary one. How are you seeing that then? And I think what I hear from you, Richie, is you said earlier how this converged view of the complete stack is insanely powerful. And then you talked about how you can start to use these tools now for observability in highly unexpected ways. And I expect there's some corollary there. And then, so integration then becomes the big challenge. Is that right, Bartek?
Yeah, we have, so many different tools, so many different observability systems, tools, APIs, specifications. That's why, we have to, I want to kind of highlight that as we maintain Prometheus, the majority of, maybe not majority, but lots of work were put into ecosystem of exporters. So those kind of adapters, you would call it, that adapts different metric signals, maybe a Linux system, how to expose a Prometheus metrics from that, how to allow aggregations and counters and those measurements to be taken. And we have ecosystem, mostly community driven, of those exporters for StatsD exporter, JVM exporter, like all of those kind of essential tools where we're kind of putting their exporters to make sure it's working with Prometheus. And this is like the major reason why Prometheus is so popular right now, because you can essentially monitor everything, including like wind machines. I think we have something like that on some PromCon, someone talking about, or literally how your plant is growing. Like, I don't know, like some kind of interesting statistic I think we got from the Grafana blog at some point. But it is essential part and integral part of the whole system to have those integration, and it takes time to build it. That's for sure.
So, Richie, following up a little bit, who's doing the work and getting this data stored? So you're storing petabytes of historical data. You're trying to do it in a cost-efficient way to achieve what you're talking about as the promise here. Who's doing that work now? And I know it depends, but who are you seeing doing the work? I mean, what are they doing?
So with the compression which Prometheus and Cortex and Thanos by extension have, petabytes of just metrics is humongous, I dare say. But yes, it depends, but it depends on different angles. So notwithstanding that you have different organization or different ways to organize within, it depends on the size of the thing and how much ownership the teams have over that part of their thing. In the pure Prometheus model, every team running a service runs their own bunch of Prometheus servers, some of them for actual like production, some of them for experimenting, some of them maybe even on their laptop to just write something out, get some data, do whatever, and stop that thing, or maybe not. That is a very, very decentralized way of working, where the service ownership teams have very strong ownership of that part, which is very SRE driven and everything. Yet obviously you want to have this complete overview of everything, and then it becomes interesting. The classic case would be Federation, where Prometheus sends, or upper Prometheus service can scrape downstream servers and get data into them. But this is an operational model which most people don't like. So Prometheus has something called the Prometheus remote read-write protocol, which allows you to push metrics from Prometheus to other systems, primarily Cortex and Thanos. And those would then usually be owned by a dedicated team. But you can take this even further. You don't have to run your own Prometheus. You can just also distribute this or put this onto an infrastructure team or an observability team, and they keep running this for you. Or you can be even more extreme, and that's what we are seeing, especially with users who are not too familiar with the cloud native world and just want to onboard themselves, obviously at speed, but still have, or maybe they just have a lot of legacy stuff. Anyway, there is an agent model, which is currently still a Grafana agent, but all the Prometheus bits are being put into a Prometheus agent from this, which is basically a single binary. It might even contain a few exporters to transpose data into something which Prometheus understands. It does all the data collection work and directly sends the data to Cortex or Thanos or something else through remote write. And then you basically have a single team, or maybe several teams, depending on region or so, and they own the complete observability stack and do this as a service for the complete org. Of course, the overhead of running those binaries to just collect the data is negligible.
So let's get into a little. You talked about Thanos, and so Bartek, Cortex, and Thanos. They're both open source, highly available Prometheus setups with long-term storage capabilities. How are services like these being used for observability, and what are the differences between them?
Yeah, good question. So there is a long story behind both projects. Both projects were created by the Prometheus, co-created by Prometheus maintainers, and they kind of were started from the Prometheus world on the Prometheus principles, making sure we kind of reuse exactly the same sometimes code, directly importing Prometheus kind of Golang code. And at the end, how it started from different angles, where Thanos tried to incorporate this decentralized model and didn't want to change too much in this model. Within Thanos, in the initial kind of concept, we envisioned that you essentially adapt the Prometheus and prepare some kind of central observability with object storage as a main, and the kind of main storage that abstracts away so many problems. It's very cheap and actually fast enough for most of the cases. And you set up some querying layer, which is kind of like federation of Prometheus, but without this duplication of data. You essentially fetch what you want from the places that has the data you need to evaluate your query. For example, for how many requests your services for this job actually made yesterday. And this was kind of the initial idea. And it worked well for many organizations, versus the Cortex started from very different use case for like a proven, highly scalable service, SAS essentially platform that accepts replication, accepts the remote write. And this allows the Cortex team to focus on a very high scalability, where you have thousands of users on the same platform, using observability on metric side as a super simple and kind of transparent. They don't see each other. There's multi-tenancy and authorization, all of those kind of things centered to make sure everything works for a vast amount of tenants, essentially, right? And it's interesting because different organizations who wanted something maybe a little bit cheaper, maybe easier to set up, maybe simpler, they went for Thanos. People who really know that they will end up with like high scale, and they want to make things just work and start from the high scale and be super fast and high performance. And they maybe chose Cortex. But at the end, Cortex learned the simplicity of operational model. They moved to the kind of Thanos storage model and Prometheus storage model a little bit, and kind of diverged into more cheaper option as well. And Thanos, seeing that scalability and super high performance of queries is also important, so we introduce the remote write capabilities. So at the end, the concepts are very close, and we are getting like closer to the middle of use cases. So it's amazing to see that we are also collaborating. Like we have Thanos maintainers, also Cortex maintainer, and we have kind of we share the code and ideas. And I want to highlight that this kind of is not competition at that point, even though you can set up really similar size of observability, with this and this, and have a like comparable performance and comparable, I guess, price. But the amazing thing is that we are experimenting with different technical and different feature set and different optimizations pattern, and we can actually get much grow much farther with having two projects trying different path and actually learning from each other which path was better and joining that. And we've seen that on many places. And I won't be you'll be bored if I will be starting talking about some indexing patterns and block storage and shuffle sharding and stuff like that. But all of those are super great, and I'm super grateful that we have those two projects which seemingly compete, but it's actually very powerful in the CNCF.
Now, Richard, you're the OpenMetrics founder. What is the corollary to OpenMetrics to what we're discussing here? And then I'd like to just ask you a last question before we go to questions from the audience. So why don't you help me with that? Because I want to make sure we do cover OpenMetrics, because you did play a gigantic role in that, clearly.
Prometheus was founded 2012. It stabilized its exposition format, which is the lingua franca of how to transport metrics through the network from a system, one of those exporters and integration, doesn't matter, to Prometheus, stabilized in 2014. And we saw uptake in the community and in the open source scene, but we didn't see a lot of uptake in actual competing projects or companies. Like Prometheus is not a company, but there are companies which make competing products. Of course, there was this taint of the Prometheus name being attached to that thing. So basically, CNCF asked us to branch this out into a different thing, just the standardization of the wire format of Prometheus, and the wire format obviously also encompassing the data model. So this OpenMetrics is at its core a super careful, compatible evolution of the Prometheus exposition format under a neutral brand. It's been submitted to the IETF, so it also gets like a real stamp of approval from an outside org and everything, as a standard which can be used to transport metrics. There are things in OpenMetrics is going wider than just Prometheus in a few carefully backwards compatible ways. So, for example, OpenMetrics mandates text format on both sending and receiving side, but it also allows protobuf in case orgs want to have their optimizations this way. We are super quick with the text parsing, yet some prefer proto, and so that's supported and in there. OpenMetrics also supports push on the wire, like directly from the initial monitoring target, which is something which Prometheus is superbly unlikely to ever support. Yet there are valid use cases where you can have push. So we made sure that we allow this in the spec, and also put in all the considerations which are like pull and push are almost the same, and most of those discussions are borderline religious. The one super different property between the two is in a pull-based model, I know what my targets are, what should be there, and I know immediately at the point where it should be existing if it replied, if it exists, and if it is in a healthy state or not. And this, this complete overview at all times of what should be existing, and B, this tight coupling between the knowledge of that should be existing right now and that is existing right now, allows you to do a few tricks and optimizations. So we put in the considerations into OpenMetrics how you can try and emulate this, even though it cannot be perfect. The other thing where OpenMetrics led from ahead of Prometheus is exemplars. When I started OpenMetrics, and it still didn't even have a name, I already wanted to also have logs with label sets properly attached to them, and I also was convinced we would need to have traces also. At that time, there wasn't really anything which was as flexible and powerful as Prometheus with its label sets. So it was always the plan to always to also have logs and traces in there. We met with the Open Census people and a few others like Influx and such in 2017, trying to get those standards together. And one of the main things, or actually the main thing I took out of that thing, was when Googlers told me that you shouldn't be putting labels on traces. Of course, searching for traces didn't scale. And when Google tells you that searching for something doesn't scale, you better listen. So we put exemplars into OpenMetrics. Exemplars are super simple. They're just an ID or a string which you can attach to a single time series at a point in time. So those exemplars can come and go away as needed. They usually only stay around for a relatively short time, depending on how you implement it. But the point is, you have an ID which points you directly to an exemplar or to a trace. So you see that one weird spike in your latency, or you have your histogram and you have this super high latency bucket, you know a trace you're jumping to is relevant. Of course, you're coming from a metric which is also already relevant from you. And as you have your labels attached to your metric, you already have all that context, and you can just transpose that context onto the trace which you're jumping to. Same for logs, where with Loki you have a system which is like Prometheus but for logs. You have the same metadata, you have the same way of indexing your data. It's just not metrics anymore, it's logs, which allows you to seamlessly jump between those two, and also obviously to traces which are stored as exemplars or through exemplars. And that also allows you to really seamlessly move between all of those. But it also allows you to, for example, generate metrics from your logs. Of course, you have those same labels attached. So those metrics which you artificially generate immediately make sense in your complete other system on the metrics side, because they use the same nomenclature and the same labels. And that brings us back to this complete holistic overview of your complete thing.
Excellent. Well, I think we're out of time. We're ready to take questions from the audience. I want to thank you both. Bartek, any last words of wisdom before we go?
That was on spot. No, thank you for having me, and please check out the CNCF Observability and join our SIG observability calls.
Excellent, great. Well, thank you both for taking the time today, Bartek and Richard. Appreciate it.
Thank you.